Hey guys, this is Shashank, and now I'm going to solve the fifth question in the maths EndSem paper. So the question is, prove the identity that Laplace transform of f dash is s times the Laplace transform of f minus f of 0. So first the formula is L of f of t equals integral 0 to infinity e power minus st, where s is an arbitrary constant. E power minus st is called the kernel, times f of t dt. This is the formula. Now we have on the left hand side L of f dash of t equals, again, integral 0 to infinity e power minus st times f dash of t dt. Now we can convert this integral 0 to infinity as limit a tends to infinity integral 0 to a e power minus st f dash of t dt. Now it's the same thing because limit a tends to infinity and integral 0 to a, that means that turns out to be again integral 0 to infinity. So by parts, integration by parts, we find out that this can be considered as u and this can be considered as dv, derivative of v, and then we get du as minus s times e power minus st, and then we get v as integral of dv, that is obviously f of t. Because dv is f dash of t, we get v as f of t. Now L of f dash of t equals limit a tends to infinity we have by parts formula, that is uv minus integral v du. So uv, that is e power minus st f of t 0 to a, because the limits which we have taken here is 0 to a. We also get the limits as 0 to a minus 0 to integral 0 to a minus s e power minus st and f of t dt. Then we can split these into two separate parts. Then we get limit a tends to infinity, this is s, sorry, that's my mistake, e power minus st. Then we get f of a times e power minus sa minus f of 0 times e power 0, that is 1. Now minus and minus, when this goes outside, we get plus. Again, I have split the limits into both the parts, a to infinity integral 0 to a e power minus st times f of t times s dt. Now that equals, here we have limit a to infinity f of a times e power s times a minus f of 0. So when we put infinity in here, we get we get f of a by e power sa minus f0 f of 0, where a tends to infinity, right, plus limit a tends to infinity integral 0 to a. The same way I have converted integral 0 to infinity to this, we can convert it again back. Then we get integral 0 to infinity, and since s is a constant value, we can bring s outside, and we get e power minus st f of t dt. Now when we put a as infinity inside this equation, we get f of infinity by e power s times infinity. Now e power s times infinity is going to be a very, very, very large number. So some number by an extremely large number is going to be an extremely small number, which we are now going to assume as 0. 0 minus f of 0 plus s times integral 0 to infinity e power minus st f of t dt. Now this is again the direct formula for the Laplace transform of f of t. So we get the Laplace transform of f dash of t equals s times L of f of t minus f of 0. Therefore L of f dash equals s times Laplace of f minus f of 0. Thank you.